So here's our starter for today. Two problems. Number one, how much voltage is needed to push 2.5 amps through 20 ohms of through a 20 ohm resistor. Through a 20 ohm resistor. How much power is it using? So let's figure that out. We have how much voltage is needed to push 2.5 amps. What is 2.5 amps a measure of? Current. Through a 20 ohm resistor, well, that's obviously resistance. And it's asking for how much voltage is needed, so we're trying to find voltage and how much power is it using. So voltage and power. So one of the things you really have to know your variables. You really have to know, I didn't tell you that voltage, the current was I, or resistance is R, and power is P, and all. You have to know that. So solve. Well, we're given current and resistance, so we know that voltage is equal to current times resistance. That's Ohm's law. So I just need to plug in my values. 2.5 amps times 20 ohms. Now I like to remember that an ohm, by definition, is a volt per amp. That is, how many volts you need to get an amp of current to flow through it. I need 20 volts to get 1 amp to flow through that device, whatever it is. That's what 20 ohms means. So now I plug in what is 2 times 2.5 is 5, and then add a 0, so it should be 50 volts. You'll need 50 volts to get that. And then power is equal to current times voltage. And so we have 2.5 amps. And we just got the voltage as being 50 volts. Well, what is 5, what is that, 12.5, I think? Plus a 0 is 125? And what is an amp times a volt equal to? A watt. And remember, that's because an amp is a coulomb per second, how much charge flows by per second. And a volt is a measure of how much energy is being carried by the electricity. Joules per coulomb of charge. And so the coulombs cancel, joules per second, and that's a watt. So the power equals 125 watts. And look at the technique here. Given, find, and solve. Writing down the formulas that we're using. Putting in values with their units. Boxing the answers. Okay, that's all stuff I want to see you guys do. Because then it looks good. Even if your handwriting is bad, it still looks good. All right. So, number 2. Now this will give a result, and it kind of relates to problem number 1. What if in problem number 1 I just said, hey, we got 2.5 amps moving through a 20 ohm resistor, how much power is being used? Well, based on what I've taught you so far, you would have to figure out the voltage first and then figure out the power. Because this is the only formula I've given you, is power equals current times voltage. But there's another one that makes these problems a little bit easier. You can skip the step if you know this, how to do this. See, power equals current times voltage. But we know that voltage is equal to current times resistance. So what I can do is, in its place, I know that voltage is equal to current times resistance. Now you could leave it like this, but this is kind of awkward. So what is I times R? What's a better way of writing that? What is I times I equal to? I squared times R. And this is an equation for power. So if you have a situation where you know the current through the circuit and you know what the resistance of the circuit is, you can use this equation to figure out how much power is being used. And notice that it's current squared. So if you double the current through your resistor, if you double the current, you're going to quadruple the power that's coming out of that resistor, usually is heat. Now the next equation, and it said to create two more equations. This is one. It takes a little bit more work to do. I've got power equals current times voltage. Now look what I did. Over here I substituted for voltage. But there's another variable. What if I substituted for current? Well, I just take my Ohm's law, V equals I times R, and I solve it for the current. Current equals voltage divided by resistance. Okay, do you see that? Then you take this and substitute it in for the I right here. And we say, well, power equals current, but current is equal to voltage divided by resistance. So voltage divided by resistance times voltage. Now we could leave it like this, but we can kind of make that a little bit prettier to look at. What is voltage times voltage? Voltage squared over the resistance. Now this is much more common. This is a very common formula to use. If you know what the resistance is and you know what the voltage drop is across the resistance, across the resistor, you can figure out how much power is going through it by using this formula. So we have three formulas now for power. Power equals current times voltage, but power is also equal to current squared times the resistance. It's also equal to voltage squared divided by the resistance. So this gives us a set of equations that we can now use to solve for power depending on what we're given. Okay? Any questions on the starter today? That is all.